Take the equation x double prime equals a. This equation is relatively easy to solve. If we integrate x double prime with respect to t and integrate a with respect to t, where a is regarded as some constant which we can identify with acceleration if we wish. The derivative of x double prime with respect to t, if we regard prime as indicating a derivative with respect to t, an antiderivative of x double prime is then just x prime. Since the derivative of x prime is x double prime is an antiderivative of x double prime. And the integral of a with respect to t is at, and then we have an integration constant. We can then integrate x prime with respect to t, and that equals the integral of at plus c with respect to t. And we get antiderivative of x prime is just x. Antiderivative of at is 1/2 at squared plus ct. And now we're going to want another integration constant. We don't want to call this one c if we call this one c, so let's go back and call this one c sub 1 and call our second integration constant c sub 2. We see that in the process of doing two integrals here, we've obtained two integration constants. This allows us to put two conditions on our function. We could specify, for example, that the value of x at t equals 0 is 12 and the value of x prime at t equals 0 is 7. If this is motion, this would correspond to setting an initial position equal to 12 and an initial velocity equal to 7. So applying first this condition to our function, we get x equals 1/2 a times 0 squared plus c1 times 0 plus c2 equals, well, we have 0 here, 0 here. That's just c2, and that should equal 12. Now that's actually x of 0 equals this, and that doesn't look too good, but we have x of 0 equals c2, and that equals 12, so we conclude that c2 equals 12. And x prime of 0, well, the derivative of this function is easily found to be at plus c1, and of course we found that in the process of our integration. And that's x of t, not x of 0, so that x prime of 0 equals a times 0 plus c1, which equals c1, and since c1 equals 7, we conclude that c1 is 7, and our function is x of t equal 1/2 at squared plus 7t plus 12. And we can verify that when t is 0, this function is equal to 12 as specified, and its derivative is equal to 7 as specified.